The function k of t helped Kira determine the rate at which electricity was being used for any day t of the month. However, to manage total electrical production, Kira needs to determine a function that will accumulate the energy used over the course of the month. So she needs a capital K of t to determine the total amount of energy used from the beginning of the month to some time. So if at time t equals 0, no electricity has been used, write an equation that can be used to calculate the amount of electricity that has been accumulated as a function of time. Okay, so we're given a rate function, and we're trying to find an accumulated function. So recall that the relationship between accumulation and rate is that accumulation is the integral of rate. So in order to find our capital K of t, that's going to be the integral of lowercase k of t from 0, the beginning of the month, to t, the end of the month. So k of t is 8 minus cosine plus 0.01 t squared plus 0.01 t. So the antiderivative is 8t minus sine t plus blah, blah, blah. Just use the power rule. Plug in t, plug in 0, and subtract. So when you plug in 0, you get 8 times 0, which is 0, minus sine of 0, which is also 0, plus 0 cubed plus 0 squared. So when you plug in 0, the function goes away. You should always double check, by the way. Just because you're plugging in 0 doesn't mean the answer is 0. If that was a cosine of t, the cosine of 0 is 1. So just be careful when you're plugging in 0. Okay, so we end up with k of t is simply this, which is the antiderivative of lowercase k of t. So that's the relationship there. So remember, accumulation is the integral of rate. Okay, now to calculate the total amount of electricity used during this month, assume that the number of days is 30 for the month. So just plug in 30, use a calculator. You're not going to do this by hand, and you get 335.488. Okay, and then C, use your calculator to examine the graph for the 30-day period. So we're graphing capital K of t, then we're calculating the average amount of electricity used per day. Does the answer match that in problem 6.144? Okay, so when you graph capital K of t, you end up with this function here. Now, the average rate, the average amount of electricity used per day is the total amount that's used divided by 30, which is 11.183. So if you're finding the average rate of change, you're going to end up with the slope of the secant, because average rate of change is always represented by slope of the secant line. If it was instantaneous rate of change, as in the actual rate, that would be the slope of the tangent. But when you're talking about the average over the course of 30 days, the average rate is going to be slope of the secant.